Right, what we're doing here is our single rotor torsion system. So here I have a large rotor and it's held fixed here. This rotor is free to rotate, it's not part of the experiment, it's free to rotate, it doesn't make any effect on it. Okay, so this is my large rotor. Again, you're working off this worksheet. So we're going to fill in this table first at the top, and we're using the larger rotor, which is 0.0312 kg meter squared. So this one. So we have it at a length of 800 millimeters from the end. So the L of the rotor system is 0.8, and we're kind of measuring this by eye as best we can with this ruler. So a little bit of error in it. There's a kind of a visual error, and also where does the chuck exactly hold the shaft? So we've got an error of about plus or minus 25 millimeters as well. Okay, so we have a little bit of error in the length of it. Okay, but over 800 millimeters, maybe that's not too bad. So what we do is we will just disturb the rotor from equilibrium, and we shortly look at the waveform on the screen and just get a measurement for that. Okay. So how we're measuring the oscillations is with this, which is a potentiometer. So it's rotating over and back with the rotor, as you can see. And basically the potentiometer just has a change in resistance as it wipes over and back. That's it, just simple operation of potentiometer. And because we're changing the resistance, we can measure the voltage change, and that's what we're seeing on the screen. Okay, so if I oscillate the rotor, you're seeing a nice sine wave on the screen, and I can just measure that with the software oscilloscope. If I just click frequency response here, I will see that the value of that is 3.126 hertz. 3.126 hertz. So that's for our first length. Okay, so that first reading was for a length of 0.8, 800 millimeters. And all we got to do is just move the rotor in 100 millimeters each time. It will move for me. So we just move it in eventually. And I'm going to repeat, and we're going to repeat that just for a couple of measurements for 0.7 and 0.6. And again, I'm going to show you sample data from that experiment. The next thing we're going to do now is just to change it up a bit. I'm now going to just do this lower, smaller rotor and repeat the experiment. Okay, second part of the experiment. The bottom table, we've got our smaller rotor that has I value 0.0078. And again, we're going to set it up at a length of 500 millimeters. Again, we're going to oscillate it, get a nice free oscillation on the screen. And we're going to check the frequency of oscillation of that. And we're getting 7.749. 7.749. And then what we do is we go move it in 100 millimeters, so we got a length of 400. Move it in another few bit, and we got a length of 300. And again, we present to you just the sample data for that and do the calculations. So that's it. That's our rotor experiment.